In this video, you will learn how to create a simple target follow functionality so the enemies or some game objects in your game can follow a target of your choice. Okay, so let's get into it. To get the starting project, go to description of the video. Click Get a Project. Download and unzip the file. Open Unity Hub. Click Add Project and select the unzip folder. Open it. In the project view, select Scenes, double-click Sample Scene. Now you are ready for the video. First, let's preview our scene. We have here one player and enemy, and we want enemy to follow the player. Click on the enemy in your scene. Hopefully you downloaded this project from the GitHub or from the link in the description. On the enemy, we have rigid body and the capsule collider. A very important thing here, on the rigid body, we have selected is kinematic, so the body will be not affected by the physical forces. And also we have here capsule collider. That's not really important here. What we want to focus on is the functionality to follow the player. When you will play the game, you can control the player. You can move, but you see enemy is not moving because we need to implement this functionality. And the player movement actually is handled in my other YouTube video. Okay, so now let's focus on the important part, and that's follow functionality for the enemy. First, we are going to create a new script. So go to your coding editors. You can just simply open any script in your scene here. What we have, we can click on the player, for example. Click on the player controller here, 3 dots, and edit script, and it should open your coding editor. Okay, and here it is, player controller in the current folder, in the current project. And we can close it. We don't need player controller right now. We will open here a scripts folder, what you have here, and create here a new file, and let's call it enemy controller. Enemy controller.cs. We'll create enemy controller. So we will start with the public class enemy controller, and it extends mono behavior. Okay, now we want this. I will actually fix the spacing. I will use indent spaces for 4 as I'm usually using. Okay, we'll define here a couple of fields, serialized fields, which will be defining speed, rotation speed, and stop distance. So let's start with the speed. So let's write here serialized field, private, float, and the speed, m_speed. That's how I'm prefixing my private serialized fields, m_speed. And this will be for movement speed. So how fast will be our enemy moving? And let's define it to the 5 units. The default value, we can adjust it later. Now we will copy it and paste it 2 more times, and we'll define here rotation speed. So how fast we'll be rotating our enemy, let's say 10 units. And then the last one will be stop distance. So how far the enemy should stop from the player. So m, and let's call it stop distance. Stop distance, and it will be 1.5 units. Let's say we can also change it. So this is how far we should stop from the player. Now we'll create here a start function and also update function. So let's write here void, or actually I'll go with the awake now. Awake is also called only wait once, or start. It's completely up to you. Let's go with the start. Don't want to overcomplicate things here. So start, and also similar one. Let's copy it, update, which is called on every frame. Start is called only initially. Okay, here in update, what we want to do actually, we want to follow the target. So we need to follow our player, right? That's very important to follow the player. So our player has a player controller. You can see here the player controller. So that's how we can get our target. And you can get your target as there are many ways how to get your target, but I will be getting our player target this way. I'll create here a private field, and I will call it transform simply. And here m_target, like this. Okay, this will be my target, which I will assign in my start script. So in my start script, I will get my target, and I will assign to this. We'll call here method function. I'll call here. We'll call here method function. Actually, function the method, that doesn't really matter. I'm using this interchangeably. So if you see me saying function or method, I mean the same thing. Okay, but we are calling here find object of type. Find object of type, and we want to find here player controller. And since my mTarget is a transform type, and here we are getting the player controller type, we will extract from it transform. All right, and we have a transform target. Perfect. So now, in our update, we will first check if we have a target. So if we actually will check if we don't have a target. So if the target is not equal to null, which means we have target, all right. So if target has some value, so we have a target, the player is in the game, we have the target, then we want to follow the target. So we'll create here a new method, follow target. So just simply, let's go ahead, call here follow target. Doesn't matter, we don't have this method yet. We can create it or just simply hover over quick fix and generate method follow target. And here we have a follow target. Okay, so now in the follow target will be the important functionality to follow the target. To follow the target, we need to compute the direction to the target. So here we have our player, an enemy. So here is a player, here is the enemy. And to compute the direction, we need to get the player position minus enemy position. And if we will do this operation, this abstraction, this will get me the target vector, the direction to the player. Okay, so that's what we are going to do. Okay, so in the follow target, we will compute the direction. We will create here a new member, private one, private vector3, call it m_direction. Back to follow target, m_direction equal, and here we'll get the m target position, so target, which is our player position, minus transform position, and we will reset y value. Okay, so this is just the functionality I have here in a vector extensions with the new y. So this basically creates a new vector where the x value and z value are the same, and the y value is the value I'm declaring here. Okay, this would be as writing this var new vector like this equal new vector3, and I would get this m direction x, m direction, this I would get a 0, and this I would get a z. All right, it's the same. Okay, so you can see I'm resetting here y and I'm keeping the x and z, but by writing this I have it in one step. So I just write here with y 0 and x and the z will stay the same in a direction. Okay, so this is much simpler. So that is just a method you can find here. Okay. Okay, so now we have a direction, which is great, and now we will compute the distance from our player. Okay, so to get a distance from your player, we'll create here a variable, local one called distance, and distance is just a magnitude of this vector. So when you do the subtraction of the vectors, and when you get the magnitude of the vector, so size of the vector, that's basically your distance. So m_direction magnitude will get you a distance from the enemy to the player, and we will check here if the distance is larger than our stopping distance. Then what we want to do? Then we want to move towards target. So we'll call here method move towards target. We don't have this method, no worries. And then right here else. Otherwise, what we want to do? So this means that we are too close to the target. Okay, so we are in the reach of the stop distance. So in that case, we want to call here stop move. We want to stop basically. Okay, and then in any case, it doesn't really matter if we are stopped or we are not stopped or we are following the target. In every case, we want to rotate towards the target. So let's call here rotate towards target. Okay, so now we have these three methods to implement. So just go ahead, just hover, generate this one, and generate the last one. Okay, so these throws we can remove. We don't want to throw an exception just yet. We don't need it. And we'll continue on implementation, rotate, not rotate, we want to move first. So we will be implementing move towards target first. Okay, so let's go into this method, body. The first thing in the move towards target, we will get m direction, and we'll assign here m_direction, and we will normalize it. Why we are normalizing it is just if the target is further from the enemy, the direction would be larger, right? So the vector would be larger, and this would mean that we would be moving faster. And by normalizing it, that every direction size will be the same. So that's why we want to normalize it. I can actually show you an example when we'll get this implementation done. Okay, so we are normalizing our direction. Okay, now create here Vector3 or simply var if you want, doesn't really matter. And this will be our movement. And to get the movement, we will get a direction multiplied by the movement speed and multiplied by the time delta. So get a direction multiplied by the speed multiplied by the time delta time, and this is your movement. And you have a transform position and just increase it by the movement like this, and this should start moving the enemy. We should already see the movements. When you will save this and you will go here, you should see that the enemy, when you play the game, should start already moving towards you, and it is not moving because we don't have a script on the enemy. That's very important. Click on the enemy, and here down you have a add component. Click add component and search here for enemy controller and attach it to the enemy. I'll just move it up here so you can actually see it. And with these values we can keep as they are, and we can play the game, and now the enemy should follow us. You see, it is following. It is following the player. All right, amazing. Okay, let's see the example I told you that when we will be not normalizing it. So let's not normalize it, just let's comment this out. And you should see that the movement speed will be not consistent. When we will play the game, you saw how fast it went? Okay, so that's why we are normalizing it, because if the further the enemy is, the vector will be larger and will be moving super quickly. That's why we want to normalize it. So we want to normalize the magnitude value to 1. Okay, so this is done. What did you notice is that we are not applying any animations, but animations I think I will leave for the last thing, but we are not rotating towards the target. So yeah, that will be the next step. Actually, I will reorder this a little bit. I want to copy this method, remove it, and move it just up here, like this. And I will continue work on rotate towards target. Okay, so we will just simply compute here our target rotation, right? And we will use the quaternions and look rotation, and just look rotation into the direction, and that's it. That's how you can find the rotation. That should be target. Oh, we don't have a target rotation. Aha, okay, so we need to create this field. So up here, right here, private and quaternion and m_target rotation. Now let's get this, go down into your rotate towards target, get here m_target rotation, and this will be the rotation we want to rotate to. And simply just got here transform rotation equal m_target rotation. Save this back to the game. Let's play the game, and the enemy should already rotate towards us. As you see, when I'm too close and the enemy is rotating, it's rotating quite quickly. It doesn't look that bad actually. I thought it will look worse, but yeah, it doesn't look. But if you want to normalize also rotation, so it's not happening so abruptly, you can also interpolate. Linear interpolate also rotation, and you would do it like this. You would write here quaternion and slurp for spherical linear interpolation, and here you would get your current rotation. The second parameter, second value would be your target rotation, so m_target rotation, and the maximum change of the rotation here. So this you would get m_rotation speed multiplied by the time delta time. This is maximum allowed increment per frame of the rotation. And that's how you would interpolate it. When you will save this, and now let's see if we will see actually any change, but the rotation should be smoother. That's what you should see. Okay, not much difference I would say, but that's, yeah. Okay, so what's the next step? We are rotating, and now we could handle also. I think we are done here with this. We can actually handle already animations, because as you see, the current animation is idle animation, and we're not doing much. Actually, the animations I explained in my player controller tutorial, but let's take a look at the enemy. Click here on the animator on the right side, and here you have an animator controller. Double click it, so it will open animator window. If you want to move here, you can just hold the Alt or Option key and press the mouse and you can move. And select your locomotion, which is a blend tree, and double click it. In the blend tree, you can see you have attached two animations to it. One animation here, you can notice here on the right side, one animation attached here is the idle animation, which is the default animation, idling, which is just standing and doing nothing. And the second one is charge, which is the moving animation. And here is a threshold. Here is a threshold 0, and here is a threshold 1. And all of these thresholds are affected by speed. You can see the speed value here. And the speed is the parameter from your animator. And the speed parameter you can actually change from your code. So when you want to test it out, just select your blend tree here. See here, this blend tree? As I'm moving my mouse, click at this blend tree and click here to play. Here, you can see your enemy is playing the idle animation. But when you will be changing the speed, notice this. Yeah, I'm changing the speed. It started moving and it started running. So by changing the speed, we can change the animation here. Okay? So blending between the idle and speed, values 0 and 1. And this is affected by this speed here. This speed here in the parameters. So when we'll change the speed to 1, it will be running. When the speed will be 0, it will be not running. Okay, I think that's clear. So now we can go back to our scene view and we can go to our code. Now we need to get your animator. So in the start, we'll get the animator. First, let's get the reference to it. So write here private animator, not animation, but animator, m underscore animator. And under the m target, let's write here m underscore animator equal get component and animator. All right. Just get us animator. And now we can change its values. So go move towards target. Okay. And here we can change the animation values. And we will do it similarly as we are doing with our player. In the player, we are keeping the float value of movement speed, which we will changing from the 0 to 1. And this value we are assigning to the animator. So let's go back up here. I'll create this variable private float and call it movement speed blend. M underscore movement speed blend. This way, the same it's handled in a player controller. Okay, movement speed blend will go to our move towards target here. And we'll be changing the value of movement speed blend. So I told you it has to be 1 when we'll be running. So m underscore movement speed blend equal, and a math larps will be larping here, so interpolating value, and we'll be interpolating a value from the current value, whatever the current value is of movement speed blend, but we want to move it towards 1. We would like to movement speed blend become 1. That's why I'm writing here 1. And the change of the increment will be time, delta time multiplied by the movement speed. This way. And then we have the value, and we can access animator and set float, and we'll be accessing the speed parameter as I showed you in the animator, and we'll be changing it to the m movement speed blend. Okay? And when we'll be stopping, copy these two lines, we'll be stopping, paste these two lines here, we'll go the other way, we'll go other direction, we'll go from the current value, which should be 1 when we are stopping, and we'll go to the value 0 because we want to stop the player. Okay, so we'll go to value 0, and this will stay the same. Okay. Now, please save this, and you should have already follow functionality when you will play the game. The enemy should follow you. It's quite fast. It's going to the player very quickly, but we can change it. When you click on the enemy, here you can speed decrease to 3, let's say, and you see the enemy is much slower. Now we are able to run faster than the enemy. Okay, and you can also change the stop distance. So when the stop distance will be, let's say, 1, you can see the enemy will get closer to you, or 0, it will go very close. It's not very good, actually. Let's say 1.5 was fine, so 1.5 I will leave. Okay, just remember the changes you do here, when you will stop the game, it will be removed, so you need to do changes in your editor view. In the running view, when you're running your game, doing the changes is good for testing, but don't forget to apply these changes after you stop the game. And here we have it, follow functionality. There are a couple of problems with this. One of the problems is when you duplicate and create more enemies. So click here on the enemy on the left side in a hierarchy and press Ctrl D or Command D to duplicate, or right click here and click here duplicate, and just duplicate it multiple times. Duplicate and move it. Duplicate and move it. And continue this until you will have multiple enemies like this. Okay? And you will see what the problem is. When you will run the game now, they are following the same path, and eventually they will merge into one path, into one position, and it looks like only one enemy is following me. So this follow functionality is good, but when you have multiple enemies, this can happen. And how to fix it is to apply some changes, right? To detect the enemies and maybe do some separation of the enemies. And this will be covered in my other video. I will show you how to implement separation algorithm, Boyd algorithm, so the enemies are aware of their neighbors and they are running as the unit and not really merging into the one position. So we have a follow, which is great. You can see it's a very simple functionality, but to get a more complex behavior, we need to apply more changes, and this you can find in my flocking algorithm or Boyd algorithm video you can find on YouTube. Okay, that's it from enemy follow.